Ilya Prigogine and the Arrow of Time. First, biographical. 1. Prigogine was born in Moscow a few months before the Russian Revolution of 1917 into a Jewish family. His father, Ruvim Abramovich Prigogine, was a chemical engineer at the Moscow Institute of Technology. His mother, Yulia Wichmann, was a pianist. Because the family was critical of the new Soviet system, they left Russia in 1921. They first went to Germany and in 1929 to Belgium, where Prigogine received Belgian nationality in 1949. Notice, Prigogine later, in 1977, received a Nobel Prize in Chemistry, same line of development as his father. His favorite pastime has been playing the piano, especially when cutting classes in college. This is what he inherited from his mother. 2. In 2003, he signed the Humanist Manifesto. 6 primary beliefs of the manifesto are: 1. Knowledge of the world is derived by observation, experimentation, and rational analysis. 2. Humans are an integral part of nature, the result of unguided evolutionary change. 3. Ethical values are derived from human need and interest as tested by experience. 4. Life's fulfillment emerges from individual participation in the service of human ideals. 5. Humans are social by nature and find meaning in relationships. 6. Working to benefit society maximizes individual happiness. 3. He was interested in a lot of different things, for example, art, archaeology, and music. He died in 2003 and was buried with honors. His main ideas. 1. Order emerges out of chaos through self-organization of nature. One example from the book is Future Given, published in Moscow in 2005. Quote, if you take some liquid and heat it up from the bottom, you will observe a heat disorder which is chaotic. However, as you heat up the given volume of liquid more and more, a moment comes when certain vortices appear in the system. These vortices lead to an organized structure known as Banach cells. Billions of molecules move within it and form vortices. Hence, this equilibrium leads to an order Another example. Amorphous cubes transform into ordered 3D meshes of crystalline nanowires under hydrothermal treatment at 200 Celsius. 2. The cubes above are examples of open systems, that is, ones in which there is an input of energy matter information from the outside of the system. Open systems are opposed to closed or isolated systems, in which there is no external input. These latter are not realistic systems. Prigogine showed that some open systems are capable of making a qualitative jump into more complex systems, exhibiting a greater amount of organization. In his own words from the Nobel Prize lecture, quote, "Non-equilibrium may become a source of order." End of quote. 3. According to the second law of thermodynamics, all systems progress towards maximization of entropy. Merriam-Webster's dictionary defines entropy as, quote, "a measure of the unavailable energy in a closed thermodynamic system that is also usually considered to be a measure of the system's disorder. Broadly, the degree of disorder or uncertainty in a system." End of quote. One example of the second law. After a work in my robotics laboratory, there is disorder, as there is waste on the tables and on the floor, instruments are strewn all over, projects are being left undone and in progress, etc. However, in nature, we observe the opposite tendency as well, as for example, when certain people come into the lab and to clean it up, tidy up the instruments, put work in its proper places, make up plans for the future, discuss projects to be done, etc. 4. A fundamental property of nature seems a simultaneous creation of order and disorder, or simultaneous creation of pairs of opposites, or development in opposite directions. Prigogine says, "Today we know that an increase in entropy doesn't come down only to an increase in disorder, as order and disorder appear and exist simultaneously. For example, if we put two gases into two connected volumes, for example hydrogen and nitrogen, and then heat up one volume and cool down the other, as a result of the differences in temperatures, in one volume there will be more hydrogen and in another more nitrogen. In this case, we are dealing with a dissipative process, which on the one hand creates disorder and simultaneously, through the heat flow, creates order. Hydrogen in one volume and nitrogen in another. Order and disorder, hence, are closely related. One includes in itself another. 5. According to Prigogine, a key property of nature, which all prior physics overlooked, is the arrow of time. That means all universe and all objects within it, including the people, develop in a certain direction. This is a fundamental concept, and it unifies all universe. Simultaneous evolution of all in one direction of time. Thus, in the book Is Future Given, published in 2005, he says, quote, "Biology is evolutionary science. Cosmology is also an evolutionary science. Hence, if basic principles of physics were reversible in time, it would be truly strange." End of quote. Basic principles of physics are irreversible in time. Prigogine argues. That means, while some processes, such as a simple pendulum, are almost reversible or close to it, most processes in nature, for example a two-part pendulum, are non-reversible. In fact, a two-part pendulum is a basic illustration of chaos theory. Six. More on the arrow of time. He says, classical point of view of physics does not correspond to historical, time-oriented evolution, which we observe all around us. We found out that the universe is developing. That is the main achievement of cosmology since the Big Bang. End of quote. That which examines the universe as static, for example, Aristotle's logic or capitalist ideologists, are primitive investigations of nature. The modern view sees static as a limited example of the developing universe, oriented in time. The basic verdict seems evolve or die. 7. The arrow of time points in the direction of the increasing correlation between various particles in the universe. In the words of Prigogine, quote, the physical direction of time is the direction in which correlations increase. In the course of time, more and more particles become correlated. From this, it is possible to extrapolate that the goal of the arrow of time is when everything is related to everything. In the words of Pink Floyd from the song Echoes, and I am you, and what I see is me. 8. Arrow of time implies development. Development proceeds in evolutionary fashion until a bifurcation point is reached. Bifurcation means a point where two or more outcomes of an unstable situation are possible. From this point, normal evolution takes over until the next crisis, thus resulting again in several possibilities. Thus, development is highly uncertain, as several possible roads may be taken at each bifurcation point, and the number of possibilities increases as each point is reached. According to Alvin Toffler, who wrote an introduction to a book of Prigogine and Stenger's Order Out of Chaos, quote, according to the theory of change implied in the idea of dissipative structures, when fluctuations force an existing system into a far from equilibrium condition and threaten its structure, it approaches a critical moment or bifurcation point. At this point, according to the authors, it is inherently impossible to determine in advance the next state of the system. Chance nudges what remains of the system down a new path of development. And once that path is chosen from among many, determinism takes over again until the next bifurcation point is reached. 9. Development implies a system, that is, a group of interacting things that form a unified whole. Each system has a number of subsystems within it, and each system, in turn, is a part of a larger metasystem, as for example a student is a part of a class, and one work is a subsystem of the student. Two or more subsystems may develop in different directions and at different speeds. Hence, several parts which have formed a harmonious whole through a number of fluctuations grow out of balance, out of tune with each other. This leads to a crisis, a bifurcation point. 10. Development between bifurcation points proceeds according to probabilistic laws, according to quantum theory. That is, one event is more likely than another. However, at bifurcation points, which are nodes far from equilibrium of a system, laws may break down, and chance plays a large role. In a world ruled by probabilistic laws, there is little place for novelty or creativity. In a world ruled by chance and chaos, everything is absurd and doesn't have a cause. Combination of probabilism and chaos allows us to have a more realistic picture of the world, in which there is a room both for causality and novelty, for certainty and uncertainty. In the words of Prigogine, quote, "What is now emerging is an intermediate description that lies somewhere between the two alienating images of a deterministic world and an arbitrary world of pure chance. It is the narrow path that avoids the dramatic alternatives of blind laws and arbitrary events." End of quote. 11. A fundamental property of nature is symmetry. At equilibrium point, we observe symmetry of parts with respect to each other. At points far from equilibrium, that is bifurcation points, we observe that symmetries break down. 12. Evolution of the universe is conditioned by the fact that it is inherently unstable, which is manifested by the unequal number of particles and antiparticles within it. If the number was equal, we would have an explosion and no universe. Evolution, hence, is akin to the arrow of time, and both are fundamental properties of nature. As Prigogine says, an atom desires to survive, hence it forms a molecule. A molecule desires to survive, hence it forms a cell. And a cell desires to survive, hence it forms an organism. 13. The disequilibrium that is present in the universe is what drives it towards self-organization. Birds Bird flocks and human societies are two examples of self-organizing systems. Insight of Prigogine into self-organization of matter, in opposition to the second principle of thermodynamics, is better illustrated in a TED lecture on Big History of David Christian. Here we see how universe develops to produce stars, planets, and eventual life and consciousness. 14. Development is accelerating. This we can gather first from the increasing acceleration of the galaxies as they fly apart from each other. Quote, in 1998, two teams of astronomers announced that not only was the universe expanding, but it was accelerating as well. In fact, the farther away a galaxy is from Earth, the faster it is moving away. Second, we notice the accelerating rate of progress of the mankind. For example, compare the rates of development during the Old Stone Age, Paleolithic times, and the modern era, the epoch of information technologies.